Okay, welcome everyone. So those that are online and those that are here, well, limited number, but still we're there. So welcome to the people in China from Shanghai. So the session today is about high throughput experimental databases. But as you have seen in the format of the conference, we are introducing the sessions with a general presentation. And today we have the chance to have with us Professor Luiz Olavo Bonino from Twente in the Netherlands. And he's been involved in the original FAIR effort. And so he's going to be presenting this FAIR effort to us. And we thought that there was a really nice introduction to the whole workshop. And so we're looking forward to nice interactions among you there and us here. And hopefully it's going to work fine. Thank you very much, Luiz.
Thank you. Good morning, everybody. Good afternoon or evening from people in the other parts of the world. So the idea of this session is to give an introduction on FAIR, on the FAIR principles, but not only talk about what FAIR is and it's not, but also how can we follow the principles in our daily activities. So as probably you already heard before, FAIR became a hype, and as any hype, there is a certain amount of inflated expectations. And the idea of this presentation is to set the baseline. So this is what we are expecting, this is what we can do, this is what we cannot do now, and so forth, but we are working on that. So as Gianmarco said, I've been involved with FAIRs from the beginning. I attended the first FAIR meeting in January 2014, and since then I've been working almost exclusively on designing and developing technologies to realize the FAIR principles, or to support the realization of the FAIR principles. So just as a context, so what we have nowadays in our daily activities, and the larger the organization we are dealing with, the more complex is the environment, is this variety, this heterogeneity reality. So we have an enormous amount of technologies, platforms, providers, and it's not because we find it fun to deal with this complexity, is because the reality is complex and we have solutions that solve specific problems, but because we have a variety of different problems with different solutions, we need to use all these different things and hopefully get them as integrated as possible, so we can have a generic overview of the organization, of the activities. We can have some kind of efficiency in our daily operations. So when we are looking at the data specifically, so there were several surveys, papers about how people dealing heavily with data, how they spread their time. What's the time division? What do they do? And this is just one of them. I've read several of them, and they are basically pointing to the same direction. If you look at here, we have building draining sets, cleaning, organizing data, collecting data sets, mining data for patterns, refining algorithms, and other things. But if we look closer, 79% of the time is spent in collecting the data set and cleaning and organizing. Why is that? And here, of course, you're only spending time working with data after you found the data. But we are not considering in this kind of surveys the enormous amount of times when we just don't find the data. We search for quite some time and we never find it. So, but here, collecting the data set, so figuring out how can I get my hands on the data, and then how can I organize, clean up, because there's a lot of stuff that maybe I don't need, and organizing, and try to figure out how can I combine this with other stuff. This is roughly 80% of our time. Imagine that you work as a scientist, you have been trained for a good part of your life to master your domain. And then what you want is to analyze the data about your domain, come up with some conclusions to improve the state of the art. But you are not doing that for 80% of your time. So from the 5 days of week, you're doing your job 1 day. The other 4 days, you are just wrangling data and cleaning up. You're doing, housekeeping stuff because the data is not in a good shape in the first place. So this was a reality in 2016, was a reality before, and is still in grand part is still a reality. So when we try to break down this problem, we see that first thing, of course, and naturally, we need to find the data. We cannot work with anything that we haven't found. Then we have, once we know where it is, we have to access, we have to check whether we are entitled to do that. And if we are, how can we manage, well, what's the procedure for us to get our hands on the data? And then we, in most of the cases, we need this data to be interoperable because we need to integrate this with something else. Nowadays, it's rarely the case that one data source is going to be enough for your whole analysis or your whole activity. You have to combine with different things, with different systems, different analysis algorithms, and so forth. And in the end, what we want is to reuse. We want to optimize the resources that we spent creating the data in the first place, and then we would like this to be used as much as possible for the purpose that we intended and for other purposes as well. It's often the case that some data sets are created for one purpose and they serve many other purposes in other contexts and so forth. So it's not coincidentally that these steps, the initials of these steps give place to the acronym of FAIR. And FAIR, well, the acronym and the principles were born in January 2014 in a conference, for the conference in Leiden, the Netherlands, organized by the Netherlands Design Center and the Dutch Tech Center for Life Sciences, where 30-something people from all around the world got together to discuss those problems. Situations like, oh, I know that we had the data. I know that my PhD student worked with on this data for 4 years. Where are the data? Oh, it was in the student's laptop. It he or she graduated, and have no idea where is the data. So that's very common, and this cannot happen, right? Because we are wasting resources. So after that meeting in 2014, when these things were discussed and the acronym was created, was not something that we created before, was created as usual. And being back here in person after 1.5 years, is an achievement, I think, because the acronym of FAIR, and I think that part of at least the widespread acknowledgement of FAIR is due to this easy to grasp acronym. It was born in the drink during the drinks in a kind of social interaction that we wouldn't have much if we were zooming from all around the world, because then we will be in the next meeting, and so forth. So 2 years later, in that meeting, we spread ourselves in 3 groups. One for where I participated. I still participate in that. We are aiming at developing technologies to support the realization of the FAIR principles. Another group was advocacy to spread the word around. And the other one was to try to secure funds for these activities. Then we got together and other people joined after the meeting in 2014. And then during 2015, we wrote this paper that was published in 2016, the FAIR Guiding Principles for Scientific Data Management and Stewardship. Surprisingly enough, it heavily cited, not because of the breakthrough scientific insights, because it's just a list of principles and some motivation, but I believe that's because it touched a need, a pressing need that we all have. How do we manage our data better to have a more efficient work? So a little bit on the outreach part. So for our surprise, 6 months after the paper was published, we saw nobody still nobody know how this happened. It was explicitly mentioned in the official report of the G20 summit in China. And then a few months later in 2017, the same happened at the G7 summit. And from 2017 on, the European Union embraced that. FAIR started being part of the manual, the research manual for Horizon 2020. It's still in for Horizon Europe. And then Europe started organizing to develop what's called the European Open Science Cloud. The idea is to be based on the FAIR principles and connect the research infrastructures throughout the Europe with a FAIR layer between them so they can be connected, interoperable, and then we can have a seamless as possible integration of these diverse services, infrastructures, applications, and so forth. The principles, the FAIR principles, were primarily targeting machines. It's not because we believe that humans should be put out of the game. It's the opposite. It's because we think that humans are essential to the process, but essential in the places that we excel. So we cannot handle anymore the amount and complexity and variety of data. We cannot look at billions of data items to check everything. Machines can do that efficiently. So the principles were targeting machines, so they can do the heavy lifting for us. So the machines can help us by doing the heavy work, and then we can focus on the things that we are good at. But first, they need to understand what we mean, and understand, of course, is a very in a very loose sense, because it's more in being able to interpret certain type of information and so forth. And then these are the principles. I imagine that most of you have at least seen them. So they are split in these 4 different aspects. We have 15 principles included, some principles, to try to give some guidance on how do we deal with data, but not only data, any kind of digital artifact. So in the principles, I'm going to mention this, it's not only about data, it's about services, it's about vocabularies, it's about applications, APIs, and everything that can be done digitally. We can apply the FAIR principles. But first, let's start what FAIR is not. So as I said before, because it is a hype, there is an unfair amount of expectations that are doomed to be frustrated. But so it's important that we got it. It's not a silver bullet. It's not going to solve all the problems of humankind. It's not covering all the aspects that we eventually need. It's the baseline for guarantee optimal interoperability and reusability at a certain level. So FAIR is not a binary state. It's not the case that you are going to be 100% fair. If not, you are unfair, completely unfair. It's not the case. That's why we have 15 principles. You can choose to follow some of them. And the choice should be based on your goals, what your purpose. So we have been conducting a lot of activities on how to verify things. And the first thing that we do, and we're going to see later in the verification process, is to plan the verification. And the first point on planning the verification is that, why are you doing this? What do you want to achieve? And depending on what you want to achieve, you can focus on a certain set of the principles and not on the other ones. Of course, in the long term, you may aim to fulfill all of them. That's fine. But if you try to do all at once, you're not going to to get anywhere. So you have to start with the, maybe the low-hanging fruits or your priorities. You have to prioritize somehow. It's not a standard, so it's a set of principles, not a set of standards. There will be multiple implementation choices to be done. Of course, we need to converge in some choices, because then we can guarantee higher and higher levels of interoperability. But the whole thing was set as being as open as possible, as constrained and agreed as necessary. It's not new, so the acronym may be new, may have been born in 2014. But if you look at that, and I've heard many people saying, and of course that's always the case, people are trying to achieve or already doing or aiming at this for a long time, right? It's not all these concerns were not born in 2014. So it combines and organizes decades of concerns on how do we deal with data. So and it's not restricted, as I said before, to structured data. We can apply the FAIR principles to any type of digital object. So here in this slide, I try to highlight with different colors the different aspects, the different small things that you should look into when you are considering to follow one of these principles. For instance, F1, metadata or data are assigned with the global unique and persistent identifier. So we have an identifier to identify data, your metadata, and data, broad sense, any type of digital object, and the metadata as associated to your object. So, and this identifier should be persistent and should be globally unique. And then F2, for instance, data are described with rich metadata. So here we establish the role of metadata and the object it describes. So the metadata here is used to describe whatever you are describing. And then we should have as rich as possible metadata to help all the other principles. And in the paper, we explicitly mentioned that some of this richness that you can argue on F2 are the elements that we are describing in R1.1.2.3. So these are different things that we should look into when we are considering the FAIR principles. And then there's another way of looking at that. As you can see here, a lot of the principles have meta in parentheses. It means that this principle is applicable to both the metadata and the data. But then if you just normalize and let's take out the parentheses, only look at the metadata, we can see that all the principles are related to metadata. We can do things with metadata. And this was a good thing that the FAIR principles put a lot of emphasis on metadata, also because metadata, it's easier to manage than the data. So it's normally the low-hanging fruit. So it's easier, it's cheaper, and you can get a lot of results by sorting out properly your metadata. If you do the other way around, forget about the metadata, and let's focus on the different types of digital objects, then we have all these principles that are addressed directly to that. So you can say, okay, but F2, data are described with rich metadata. Yeah, but to fulfill that principle, you don't touch the data. You have to have a metadata record that's rich enough to be able to describe that. So that's the subject. The data in this case is a subject of the main part of this principle, which is please provide as rich as possible metadata. And the same for F3, that the identifier of the data should be present clearly and explicitly in the metadata record and so forth. So the focus on these principles that are in black are not the data, the focus is on the metadata. Another way of looking at that is that there are other third-party elements, not the data that we're dealing with, not the metadata that describes it, something else. For instance, the identifier, it's not it's something else. To have a globally unique and persistent identifier, you need to have an identification system that means identifiers that are related to either your data or your metadata. And then here we're just putting the properties of this identifier. For that says that metadata and data are registered or indexed in a searchable resource, we need to have a search engine that will be used to index the metadata of the data and so forth. Another angle that we can look at them is what's technology related. So these parts of the principles that I highlighted in red can be directly addressed using technology. So when you say that metadata are assigned with globally unique identifier, so we can have an algorithm in our identification system that we can demonstrate that provides globally unique identifiers. The persistence part, on the other hand, is something else. The same as F2, data described with metadata. So there is a way that we can create a technology that we can express metadata that's used to describe the data. How rich, that's something else. That's a social agreement. It's not technologically related, and so forth. So by having some infrastructure, my point here is that by having some FAIR-oriented infrastructure, we can cover a lot of the FAIR principles. This is the easy part. So as I said before, my role is to try to design and implement some technologies to support the FAIR principle. I always say to my colleagues that mine is the easy part. Technology, we know what needs to be done. There's still a lot of work to get everything ready and right, but we know it's a kind of managed problem. The other part, the social related issues, are the hard ones, because as we all know, if you put more than one human to discuss something, then you can start having exponential problems and discussions and time to discuss. That's our nature. So for instance, the persistent part of the identifier is not technology related. It's a social agreement that the provider of the identification system commits to keep the identifier resolving or pointing or relating to the same element for X amount of time. The principles don't say how much should be considered by the communities. Each community will have different needs for persistency. The only point here is that the identification systems should have this persistence commitment explicit, so the communities can check and verify whether that system complies with their expectation. How rich is the metadata depends on social agreements. Metadata I2, for instance, metadata and data use vocabularies that follow the FAIR principles. How fair should these vocabularies be? Should also be a concern of the communities, and so forth. So these are the parts that we have to get together and organize our communities together so we can take these decisions. And this is hard and time consuming, but will bring benefits. So here I just want to know, to show briefly that we have been designing this verification workflow process that's composed of pre-verification, the verification itself, and the post-verification, that we have to plan the verification again, identify the goals, what's the roadmap, what are the priorities, why we're doing this, what we're going to do. So get the resources together, the expertise together, the tooling and so forth, then get to and this is a verification for legacy data. Of course, you can skip the retrieve non-FAIR data if you are just creating your data or generating from scratch. And then you have analyze and prepare the data. That's the 80%, right? That we saw in the slide before. It's not analyzing in the sense of getting conclusions out of the data. It's analyzed to understand what the column A in that spreadsheet means, and the title of this column is A, and the title of the column B is B, and so on. So you have a lot of values. You have no idea what they mean and how they are related. So we have to understand this. And then we define the semantic model. So then whenever someone else gets that same data, we'll be able to reuse the data much faster. Don't need to understand all the data because the explanation is embedded with the data by means of the semantic model. And the same thing we do with metadata. And then step 6A, to make the data linkable so it can be more easily connected to other stuff. That's optional, of course, because some types of data are not suitable to do that. But if you can and the data supports, that will be useful. You can have data in different formats that are optimal for different types of activities. That's not a problem at all, and should be. We should have incentives to do that because different formats serves different purpose. And then you publish this, the metadata and the data associated, and then you can assess. You can do this before and after to check the comparison, but at least you should do this after you finish the verification to verify whether you achieve the right level of fairness that you aim at. And that was, the general message that I wanted to convey. If you have any questions, I think that we have still a few minutes for questions.
Thank you all, and sorry for the presentation. So it seems that the quality was not really nice in terms of the picture, so we'll try to sort that out for the upcoming talks. So is there questions? I will first ask in the audience, and in fact, is there questions here? Okay, maybe on the web, are there questions? Okay, I'm gonna ask one in the meantime. So you said that you were working on the tools for the verification. You didn't present them very much here.
No.
Could you say just a few words about that?
Yeah, so we have designed a kind of whole ecosystem for that. And then we have some pieces in different maturity levels. We have one specifically targeting metadata. We call the FAIR data point. Should have been named the FAIR metadata point, but the idea is to expose, it's a set of specification. We have a reference implementation, but the main goal was to be a set of specification that could be implemented in any system that wants to expose their content through FAIR metadata. So this we have the specifications, we have the compliance criteria, so we can test whether an application is really behaving as a FAIR data point and so forth. And then we have also develop as a test that can be deployed anywhere, an index where these different FAIR data points can communicate, and this index goes there and harvests the metadata of the various FAIR data points and become a data search engine or any kind of resource search engine, because you do have the metadata of all these different resources. And then we have also what we call the data stations. This is more, we just got a project that we are going to work for 1 year. It's a short project to have the final design and the initial reference implementation of what we call the data station. It's a place where not only you expose the metadata of your content in a fair way, but you allow the interactions on the data or on the content. So the idea here is that data should be should be left as much as possible where they are, just moved when absolutely necessary to avoid, data normally is way larger than the algorithms, the analysis algorithms. So keep it there, and also under the control of whoever is controlling that data. So issues on privacy and so on are kind of covered by leaving the data at the source, and then the algorithms visit the data and do all this analysis there with all this the security and privacy checks and so forth. So we are working on that. We have also a preliminary version of what we call the verifier. It's a tool that you can upload your data set, clean up, do all the wrangling. So clean up and organize and so on, and then define the semantic model, and then generate the linkable data at the end. So you can keep your original data, you can have the linkable data, and you have the semantic model, and publish that in a FAIR data point where you have also the FAIR metadata. So we are working on this kind of tools.
Okay, I don't see any other questions in the chat. Maybe a quick one. So you just said a few words about that, but I was going to ask, since you mentioned that 80% of the time is spent in cleaning the data and so on, what are the tools that are available? You just
the verifier,
the verifier would do the work there.
Yeah, we need to improve this a lot, because now in the current state it is still usable by data expert. It facilitates their lives, make it the process easier, but still we want to improve that a lot to make it more accessible to less technical people. And associated with that, we have hackathon-like events that we call BYODs, bring your own data, where we put together the domain experts. We cannot do any of this without the domain experts. We cannot define it, because we don't know what's relevant to what those things mean. So we put together the domain experts, the data owners, and the FAIR experts together to verify data and answer some defined questions.
Thank you very much. So let's thank Luiz again.